In the previous video, we looked at the proof of part A of problem 81. We're now going to be looking at the proof of part B of problem 81. And what I want to notice is that what we are doing is we are now choosing the multiplier to be a negative number. As a consequence, we ought to be able to modify the proof for part A by switching the appropriate inequalities in the appropriate definitions. And the fact that we are going to be switching inequalities is going to explain why we wind up with an inf here instead of a sup. So what I want to actually do is I want to look at the proof that we wrote in the last video, and I want to edit it to see how to make the changes. So here is the actual proof that we wrote last time. And I'm going to go through this one step at a time, making the appropriate changes because of the fact that we are now going to be looking at problem B. So my corrections are going to be in this bright green color. Now the first correction is that C is not a positive number. C is now a negative number. And our statement of our theorem has to be cleaned up because the claim is that the inf of the set C times S is going to be C times the sup of S. And now here is going to be our proof. We're still going to let P be the sup of S, but we're going to be trying to show that CP is the inf of the set CS. So I need to show that if X is inside CS, then CP is going to have to be a lower bound. So what that means is I have to change this inequality into X is greater than or equal to CP, or if I wanted to, I could rewrite that as CP is less than or equal to X. CP needs to be a lower bound for the set CS. And then I have, for the second part, I need to show that if I have any other lower bound, that it's going to be smaller than this lower bound. And the way I'm going to do that is I'm going to say that if I take somebody that is just a little bit bigger than the thing that I'm hoping to be the inf, then I can find somebody that lies between that thing that is too big for the inf and CP. So those inequalities also all get swapped. If you want to, you can rewrite this one as I want to pick Y just a little bit bigger than CP, and I want to show that there is an X hat that is trapped between CP and Y, because that means Y can't be a lower bound for the set CS. So in other words, the first thing that I need to do is I need to show that CP is not an upper bound, but we are now looking at trying to show that CP is a lower bound for the set CS where C is negative. And we're still going to let X be an arbitrary element of C times S, so X is still going to be equal to C times S for some little s inside set S. This inequality is still going to be true because S is still going to be less than the sup of S. However, this inequality has to be fixed up because C is now a negative number. So when we multiply this inequality by a negative number, the order changes. So this less than has to be cleaned up, and it becomes a greater than. And this particular inequality is true for all CS's inside the set C capital S. And this particular inequality can be written as CP is less than CS. And technically, this should be a less than or equal to, and this should be a bigger than or equal to. And so we do indeed have that CP is not an upper bound, but a lower bound. For my set S. And so we've got the first part of the proof completed. Now we look at seeing if we can modify the second part of the proof. Again, the very first thing is we're not trying to show that CP is a sup anymore. We are now trying to show that CP is an inf, and this is because C is less than 0. So what I want to do is I want to pick something that is a bit bigger than my lower bound CP. So I'm going to pick Y being just a bit bigger than CP. This could be rewritten as CP is less than Y. And I want to show that Y is not a lower bound. So all of the uppers are becoming lowers. And so here again, we're going to let Y be bigger than the thing that we're trying to show is an infimum. And this is the main hypothesis that got changed. C is no longer positive. C is negative. And when I divide this inequality here by C, the greater than has to switch to a less than. So this particular less than is correct because we're correcting a greater than over here to be a less than. So nothing gets changed over here. These things are correct. So these are correct. So that stuff doesn't change. Y divided by C is still less than P. P is still the sup of capital S, and Y divided by C is still less than P. So we still have this number line. And so we still have a capital S, a little s hat in capital S, such that this particular inequality still holds. So this is still correct. And because this is true, and now we have another correction, C is no longer positive, C needs to be less than 0, that means when we multiply this equation over here, when we multiply this inequality by C, both of these inequalities switch directions, so we have to correct these two inequality signs. We go from Y over C is less than S hat is less than or equal to P to C times Y over C is greater than C times S hat, and C times S hat is greater than or equal to P. And then we finally need to clean this up. Oops. And that up. And when we do, we get greater than or equal to's in both of those places. And so what we now have is that C times S hat is still inside C times S. And so our Y is no longer it can't be a lower bound for the set CS whenever Y is strictly bigger than CS. And hence, that means CP is indeed the inf of the set C times S. Whenever a proof is this close to the first proof, that is when a mathematician or a textbook writer is likely to say the proof of the second case is similar to the first case. Whenever you see that kind of language in a textbook, that means you ought to be able to take the proof and make editing changes to get the new proof.